Welcome to the Day 5 notes. Today we're going to talk about linear modeling. All linear models are in the form y equals mx plus b, which should sound familiar to you because it's something that you learned last year. They have two parameters, the slope, m, and the y-intercept, b. The slope, m, always tells us the rate of change, or how fast the output is changing relative to the input. The y-intercept, or b, always tells us the output's starting value, and that's when our x value is 0, which is normally time. Okay, so let's look at some examples. We have a warehouse is keeping track of its inventory of cardboard boxes. At the beginning of the month, they have a supply of 1,275 boxes left. They use boxes at a rate of 75 per day. Now we want to write a linear equation, and I know it's linear because it has this constant rate of 75 per day. That's a constant rate of change, so that's a slope. That will model the number of boxes left, y, so they're telling us our variables here also. We're going to use the boxes left by y, and x is the number of days. So we use the general form y equals mx plus b, and then we need to identify what is the m and what is the b in the context of this question. The m, the slope, is the 75 per day, and we're going down by 75 a day. They're using the boxes, so that's actually a negative 75. And then the b, the y-intercept, is 1,275 because that's how many they said we started off with. Then I can just use the general form of the linear function that I highlighted up above, y equals mx plus b, but I'm going to replace the m and the b for the context of this question. So I already have it written down over there. I'm going to write it in standard form, so y equals the m, negative 75, and that's down 75 boxes every day, so x for the number of days, and then we started off with the positive 1,275, so that goes in place of the b value. So that's my answer. The next part says how many boxes, and that's our y value, the number of boxes left, after 10 days. Well, days was our x value, so x equals 10, so I'm just going to fill in 10 in place of x in my equation. So I started off with my equation, just rewrote it copied it from up above, but I'm going to replace my x value this time with the 10. So it's negative 75, parentheses 10, close parentheses, plus 1,275. And that'll give me my y value. And I can just remember this is just a job. You can put it right in the calculator so you don't make any mistakes. And the answer is 525. And that's how many boxes will be left after 10 days. The next part says, if the warehouse needs to order more boxes when their supply reaches 150, how many days can they wait? Well, the number of days, remember, is my x value. So the 150, that's my output. That's my boxes left, or y. So I'm going to use the same formula. So again, I started out with just copying my same formula from up above, the original equation of the line, and now I'm going to replace the 150 in place of the y value, so I can use this formula to solve for x. So to solve for x, I'm going to first bring the constant over since the x's are already only on one side, so I'm going to subtract 1,275 from both sides. So on the right hand side, this will cancel. 150 minus 1,275 equals negative 1,125. And then to get x by itself, we divide both sides by the negative 75. And when we do that, we get an x value of 15. So that tells me that my answer to the question is 15 days, because remember that my x value stood for the number of days. Next question. The cost, C, in dollars of running a particular factory that produces W widgets can be modeled using the linear function C of W equals 1 and 25/100ths W plus 2,175. How do you interpret the fact that C of 100 equals 2,300? So what this question is asking for is I'm seeing a value in place of my W here, the 100 is in place of where a W would normally be. And then the 2,300 is my C of 100. So what does that mean? That means that the 100 stands for the number of widgets, since it's in place of W. This is the C of W, so that's the cost in dollars for making that many widgets. So the cost of producing 100 widgets is $2,300. The next part says, explain what the parameter 1 and 2500ths means in terms of widgets and the cost. Well, if I look at where that 1 and 2500ths is, it's with the W. So what's the one that's with the W? If we think back to that equation of a standard linear function, is y equals mx plus b. So the 1.25, 1 and 2500ths, is with the W, the variable. So that tells me that that is my slope. What does that slope mean? That means that it costs $1.25 per widget. So remember, when we say that, the slope comes from change in y over change in x. So that's why I knew it was dollars, my y value, per widget, my x value. The next part says, explain what the parameter 2,175 means in terms of the widgets and the cost. Well, thinking back again to my equation of a line from up above, y equals mx plus b. So where is the 2,175? If we think back, this is just a fancy way of saying y equals, this is the variable, so that must be my slope, plus b. So the 2,175 is my y-intercept. What does that mean? That means the 2,175 is the y-intercept representing the starting cost. Before I produce any widgets, it's going to cost me that $2,175. So that's before I even make any widgets. The next question says that Kirk is driving along a road at a constant speed. He is driving towards Denver. He knows that after 2 hours of driving, he is 272 miles from Denver. After 3.5 hours, he is 176 miles from Denver. Summarize the information given in the problem as two ordered pairs where the number of hours, h, is input and the distance from Denver, d, is the output. So they told me what my inputs and outputs are, so I'm just going to use that information to write my points. So they have to be, remember that they're always x, comma, y, input, then output. So the hours driving for the first point was 2, so 2 hours, 272 miles, that would be the point. 272. The other one was 3.5 hours, 176 miles from Denver, so that would be the point. 3 and 5/10, 3.5, and 176. Then it says calculate the rate of change. Remember, whenever we see the words rate of change, above that we're going to write the word slope. And I just wrote that small to show that we're talking about slope. Whenever we see rate of change, I always encourage my students to write the word slope above that. So first let's calculate it, and then we're going to find out why is it negative. So when we calculate it, we use the slope formula, which is equals y2 minus y1 over x2 minus x1. I also like to put the y2 and y1 labels underneath my points, so I just added those labels underneath the points so that I know that this first one is x1, y1, x2, y2. Technically, I just put them in the order that they came up here. So then I rewrote the equation down here by copying it, but now I'm going to replace each of these values. So you don't have to write them again the same exact way. I just copied it because then I thought you could see how we sub in. So I replaced each of the points, the values, in place of that value in the slope formula. Now I always use parentheses. You don't really have to because here we don't have any negatives here, but I think that the parentheses help to show when we have the minus a negative how it becomes addition. But it's up to you. You do not have to put the parentheses around them, especially in this case where they're all positive and it won't make any difference. So you could just have 176 minus 272 divided by 3 and 5/10, 3.5 minus 2 in the denominator. And then we can do this, either you do it in your calculator all in one step, showing it as a fraction, or clean up top, clean up bottom, and divide at the end in your calculator to math frac if needed to put it back in a fraction in standard form. So if we clean up top, 176 minus 272 is negative 96. And then in the denominator, 3 and 5/10 minus 2 is 1.5 or 1 and 5/10. And then we can put that in our calculator, negative 96 divided by 1.5, and we get the negative 64. And the label, if we wanted to put a label on here, they didn't say we had to, but I always think that it helps. Remember that in the numerator we had the miles, so this is miles per hour. And the question was, why is this negative? Well, if we think about the context of the question, what's happening? Kirk is driving along a road, and it's representing how far away he is from Denver. And it's as he's traveling, he's getting closer to Denver. So as time increases, the distance from Denver decreases. And remember, we talked about when one is increasing and the other is decreasing, the slope of the line will be negative. The next part says, write an equation that for the distance d as a linear function of the number of hours h. So we have to use d and h, and we know it's a linear function, so we're going to use that general form, y equals mx plus b. I know it's no longer on the page, so we can rewrite the formula so you can see it again. So first I just wrote the y equals mx plus b, but remember we can't leave it as that. We have to replace it with the information for this problem. So d instead of y, because they told us in the formula or in the problem that we had to use the d for distance. So the distance is equal to the slope, which we already found as negative 64. We have to use h to represent the number of hours because it also said so in the formula. And then the y-intercept, the starting value, well, we don't have that right now. So I have to leave that as plus b because they didn't give us a starting value. They told us how far away it was at 272 miles at 2 hours. So now we need to go and find the y-intercept. How do we do that? Well, we can use the information from a point to plug in. I know what the d is, the distance. Like I just said, one of them was 272 miles at the 2 hours. So I'm going to plug in that point in place of the h and the d value. And then I still have the plus b because I don't know what the y-intercept was. So I just chose one of the points. I used the first one. You could use either one. And I plugged in the values for y and for x to find b. So then I get 272 equals negative 64 times 2 is a negative 128, and then plus the b value, which I still don't know. To get b by itself, what do? We add 128 to both sides, so 272 plus 128 is 400. So the 400 is the b value. Now I can go ahead and plug it back into my formula that I was writing. D equals negative 64 h plus the 400, my y-intercept that I now found. And this is my equation for the problem, filling in and solving for that y-intercept. How far did Kirk start from Denver? Well, now we can use the formula. How far did he start off? That's before any time passed, so that's my y-intercept. Now that I found it up above, I can say 400 miles. And remember, that's from the y-intercept. After how many hours will Kirk arrive in Denver? So that means that he's 0 miles left to go. So that would be in place of the d. So 0 equals negative 64h, and then we just solve for our h. So we're going to subtract 400 from both sides, because that'll get the constant on one side, the variable on the other. And if we do 0 minus 400, that just stays negative 400, equals the negative 64h, and then we divide by the negative 64 to get h itself. And then we get our answer, which is 6.25, meaning 6 and 25 hundredths hours, or 6 1/4 hour. And I just left that with the decimal since it came out nice. The next question says the population of deer in a park is growing over years. The table below gives its population found in a survey by local wildlife officials. So the first question says, how do we know that it's a linear relationship? Well, remember, for linear, we're looking to see if it has a constant rate of change. So if we look at the years, these are going up. They're going up 0 to 3 to 6 to 9. That's adding 3 each time. So I just put the plus 3 on each side. Now, if I look at the deer population, what's happening to it? It's going from 168 to 216. We can subtract those to find out what's happening. That's adding 48. And then I just try to see if that's consistent. And if I add 48, I do get 264. And if I add 48 again, I get 312. So it is constant. So I know that it's linear because there is a constant rate of change. The next one says, if T stands for the number of years since 2000, write an equation for the deer population P as a function of T. So we're going to start off with P of T equals, and then we're going to use that slope y-intercept. So what's the slope? Well, we look at it's 48 over 3. That's how much it's rising over running each time. So 48 divided by 3 becomes 16. So that tells me my slope is 16. And I just wrote that off to the side in case you needed it. The 48 divided by 3 became 16, so 16 is my slope, so it goes with the variable. In this case, it's t. And then 0, since we had the starting population, it said at 0 years it was 168, so that would be my y-intercept. So this is my equation for this problem. The next question says, what does your model predict the deer population to be in the year 2014? So we're predicting the deer population in the year 2014. Well, how many years since 2000 is that? We could subtract it. Since 2000, that's 14 years. So I know my t value is 14. So I'm going to rewrite my equation, but I'm going to replace the t with 14. So P of 14 equals 16 times 14 plus 168. Then it's a job for the calculator to give us our P of 14 value, which is 392. That's the number of deer, so I'm just going to write deer. And the last question says, how many years will it take for the deer population to reach 500? And we need to round to the nearest year. So now I know that the output is 500. So I'm going to put that in place of the y value. So 500 equals 16t plus 168. And then we just solve for t. Subtract 168 from both sides, which gives us 332 equals 16t, and then to get the t by itself, we divide both sides by 16, and we get 20.75 and 75 hundredths, but they told us we needed to round to the nearest year. So if I look at my ones place and then look at the 7, it tells me that I need to round up, so my answer is 1 years. Okay, that's it for today. I know that was a lot of questions. I hope that it made sense, and have a good day. We'll see you tomorrow.